Hello everyone and welcome to our session on the Master of Business Analytics as part of our Macquarie University Postgraduate Exploration Month. My name is Ben. I'm in my final semester of a Bachelor of Actuarial Studies with a Bachelor of Applied Finance, and I'm going to be hosting today's webinar. So today I'm joined by Professor David Pitt, who is the Head of Department of Actuarial Studies and Business Analytics, and he will be providing an overview of business analytics at Macquarie. We also have Dr. George Milanovic, who is an Associate Professor in the Department of Actuarial Studies and Business Analytics, and he's going to be talking us through the Master of Business Analytics program. Finally, we also have Dmitry Semenovic, who is now the Analytics Director for IAG. So thank you all for joining today, and I'm going to hand over to Professor David Pitt. Thank you.
Oh, thanks, Ben, and thanks everyone for listening into our discussion today on the Master of Business Analytics. So what I'll do first is just tell you where business analytics sits at Macquarie University. It's within the Macquarie Business School, and what that means for you as students is that when you study business analytics, yes, you'll be studying lots of machine learning and statistical type algorithms, but you'll be doing all of that within a business context. And so very much what we'll be thinking about as we teach you is how these skills and techniques can be translated into business type problems. So we're a Department of Actuarial Studies and Business Analytics, and we sit within the Macquarie Business School. Our department formed in March 2018, and the thinking around that time was we were seeing many, many more job advertisements for graduates and other more experienced people where the tagline was business analytics or data science, and these were jobs in traditional areas where business graduates would normally be employed. So we saw a real opportunity for developing our skills and our teaching and our research in business analytics. And certainly since then, we really haven't looked back in what we've been doing. As a department, we've developed our skills in both teaching and research. On the teaching side, which I guess is most important for students thinking about enrolling in a Master of Business Analytics, on the teaching side, we've won a number of awards for our work at the university level and at the national level. And one of the things that we do that's important for students, and we'll talk more about this as we go through the discussion today, but one of the things that's really important for our students is our capstone experience. The idea there is that towards the end of your study in the Master of Business Analytics degree, what we will do is give students an opportunity to work with potentially industry partners and other academics on a problem that's of interest to us in the university, but it's also of interest to potential industry collaborators. So you get the opportunity to apply what you've learned at university on a real business problem and being led by academics who are at the forefront of the research in this area of work. So in our discussion today, as well as myself, we have Dr. George Milanovic, who is the director of our Master of Business Analytics programs. So he's going to talk a little bit about what you will learn, what you will study if you enroll in a Master of Business Analytics program, and also what are some of the pathways for entry to the Master of Business Analytics. In other words, what do you need to have done before at the undergraduate level in order to be admitted to the Master of Business Analytics. So I'll pass over now to George, who'll talk a little bit about the program. Thanks, George.
Yeah, thanks, David, for that. So maybe I'll just share my screen while I do this. So I'd just like to say that our program at Macquarie in Business Analytics is a broad program. We cover a range of core units which are targeting specific business analytics skills, such as computer programming. We have courses that do Python and R programming languages. We deal with databases. We have a number of units in applied statistics where you would learn statistics algorithms for analyzing data and machine learning techniques. But in addition to this, we also have a range of flexible units in our program. And in those units are drawn from a really wide range of disciplines, from marketing to accounting to finance and economics. And within those flexible units, as well as within our core units, we cover topics on collaboration, communication. We're developing a unit that will cover ethical issues in dealing with data and privacy. And so the idea is to form a program that will give students not just very quantitative skills, but a range of softer skills that will enable their transition into the workplace more easily. So in terms of getting into our program, let me just quickly change this slide. We basically have 4 different admission points. So I'll start, and these admission points really depend on your prior qualifications, work experience, or even recognized prior learning. So I'll start with a 2-year program, which consists of basically 160 credit points, which means 16 units or 16 courses covered over a 2-year period. So 8 units per year. And to be able to enroll into this program, you need a recognized bachelor qualification. Now, if you have some prior studies, prior learning in a relevant area of study, and for us, a relevant area of study would be either statistics or econometrics, you would be able to enroll into a shorter program. So you would be able to complete the program within 1.5 years of full-time study. And this would cover some core units where we have subjects such as introduction to computing or basic statistics and things like that, just to bring you up to the skill level where you will be then able to continue. Sorry, these are the foundation units. I skipped one. I was actually talking about the foundation units. The foundation units are the ones that will bring you up to the level of skill so that you're able to undertake core units. So in order for this, we have 2 1.5-year programs. In order to enroll this second program, you would need the bachelor qualification with a very good weighted average mark of 65 and above. To get into the other 1.5-year program that I started talking about, you need, as I said, you need prior learning in an area which is relevant to business analytics, such as statistics and econometrics. So you need a bachelor degree with those components. And if you go for that track, then you would cover core units, which are the main units that we do, and you would have additional flexible units. So for those 2 1.5-year programs, you would do 12 subjects, which amounts to 120 credit points. And lastly, if you've studied in a recognized field of study, such as econometrics, statistics, maybe computer science, and you've done really well in your studies, so you have a weighted average of 65 or above, you would actually be eligible to enroll in a 1-year program. So a 1-year program completes the entire course by doing 80 credit points, which is 8 core units done over 1 year full-time study. So that's basically, these are different admission points that we've created in order to enable people from different backgrounds to complete their study maybe in a shorter period of time, should they have relevant prior qualifications or work experience. So that's pretty much all I wanted to say about the different admission points into our program.
Great, thanks, George. So I think that gives people an idea. Basically, the Master of Business Analytics is a 2-year degree program, like most master's programs, but it's possible if you've studied statistics or econometrics or a closely related field to that previously, and you've done well in those studies, it's possible at Macquarie to complete a Master of Business Analytics within just 1 year.
Yes, that's
we
correct.
will draw on your knowledge and experience from your undergraduate program where you've studied these technical subjects in some depth, and then we'll take you further through the Master of Business Analytics and what's needed to turn you into a business analytics graduate or professional in that space. And we can do that within 1 year. So we have different options that work for different people depending on your background. So look, thanks, George. I think it'd be useful to bring Dimitri in now. So as was said in the introduction, Dimitri, who's with me here, is someone who works at IAG, and we'll find out a little more about IAG in a minute. And he's the director of analytics there. So obviously someone who hires a number of our graduates each year from Macquarie University, and someone who's very much in the business analytics space. So perhaps before we get into analytics as such, perhaps Dimitri, you could tell us a little bit, you're Director of Analytics at IAG. Can you tell us a little bit about IAG and what they do?
Yeah, well, IAG is the largest general insurance group in Australia and New Zealand, but perhaps with about 30% market share in Australia and over 50% in New Zealand, with such customer-facing brands like NRMA, it's probably quite well known in New South Wales, as well as CGU, RACV in Victoria. We are in partnership with RACV and provide the insurance product for them, as well as State and AMI in New Zealand. From the New Zealand viewers would be quite familiar with those two as well. So in general, insurance is fundamentally insuring property as well as business liability. So property, vehicles, personal houses, apartment buildings, factories, that sort of thing. Liability is insurance is basically protecting primarily businesses against adverse legal proceedings. So that's the sort of the main area of focus for IAG. It's
yeah, so sounds good to me. So IAG, one of the leading insurance groups in Australia, focusing on general insurance, which is an area of insurance I think many of us relate to. We purchase motor vehicle insurance and home contents insurance and the like. George.
Yeah, so Dimitri, I have a question for you. Being analytics director, can you tell us what analytics means to you at IAG?
Yeah,
what does it cover?
Yes, George. I mean, I think that's actually, it's a very, very good question, because it seems to be a constantly evolving and growing space. Right. So like 2 years ago, my answer would have been quite different. So now I'll get back to this in a second. Fundamentally, I guess business analytics is about finding some sort of convincing answers to some, relevant business questions. To give you some examples would be, let's say we would like to grow our business. What growth initiatives should we prioritize, and which customers should be, let's say, assigned to which type of growth initiatives? So that's a very practical business question. And often you can, at least have a bit of a go at using historical data and sort of the statistical and econometrics methodology to arrive at an answer or recommendation, and then communicate it back to the broader audience within the company, so that hopefully the decisions go in a more sensible direction than they would have if people just picked a particular area without looking at the data before. Other areas would be more kind of well-defined and cleaner areas of analytics. For example, you have two versions of your website or a purchasing experience, and you want to find out, well, which one is better. In some of these situations, you're able to run proper randomized control trial, where some of the visitors to your site see one version of experience and the other group see the other version of the experience. And then you can use sort of classical statistical techniques for experiment sizing and for sort of experiment analysis to figure out what is working better. At the same time, there are also, I guess, growing areas of opportunity in, in process optimization. In particular, when it comes to looking at the kind of existing business processes, trying to identify possible points, sort of bottlenecks, and trying to recommend some changes there. But more recently, alluding to what I've mentioned before, sort of business analytics seem to be expanding to encompass all the progress made with artificial intelligence also. So one topic that is becoming very large, I guess, in the minds of many sort of, I guess, executives in financial services and other areas is basically using artificial intelligence to help automate some of parts of their operations. So if you're familiar with technologies such as Alexa or Google Assistant, you'll know that the sort of natural language processing, voice recognition, and text-to-speech are getting to a point where, for example, now we are able to treat what historically has been a very manual process, where essentially contact centers, where you would ring up the contact center, person on the other end would listen to you, would get some details from you, type them into an application on their desktop computer, get results, communicate back, and so on. We can pick up bits of that process and now start treating it also more like a fully digitized process where everything is instrumented and the data is collected at all the points. So that kind of the type of technology coming online represents a big expansion, I guess, in the applicability of analytics to
thank you.
This process.
Yeah, no, that's really useful. And certainly the development over the last few years is quite evident in your answer. Sounds like there'd be lots of opportunities for graduates to work in the area of business analytics. Perhaps you could tell me about one or two projects where graduates have worked. So people just completing university with analytics type training, some projects that they might have worked on, and have they had the opportunity to learn about the business more broadly, rather than just simply applying the statistical techniques to the problem?
Yeah, so a couple of projects I can talk about where we had graduates working on in the last couple of years. Well, one was using a particular type of experiment design, I guess called sequential designs. To basically to build a tool or a dashboard to help our digital team to better track the performance of the randomized control trials that they're running on the website that I have alluded to earlier. One common problem in that particular setting is I guess so-called peaking or early stopping. Like if you use the classical theory of experiment power calculation, it assumes that you only do one final comparison after you have seen the data of the size that you have initially determined to get to the power and significance levels that you would like. However, in practice, of course, as you would imagine with the pressures of production, people and quotes or visitors coming to your website, obviously in certain number every day, there is a lot of temptation to check the numbers every day and then make some declarations about success or failure as soon as the statistic, exceeds certain threshold and so on. So there are some, I guess, existing theory there that kind of goes back to, 1950s called sequential experiments, going back to essentially statistical quality control sort of in manufacturing, sort of the area I think where it originated, where you can build very easy to understand experimental dashboards that are essentially immune to, you can look at them as frequently as possible, and you won't kind of invalidate your test. So we had a graduate basically research a bit of, based on a high level brief, to do a bit of research into the theory, like find the sort of the right appropriate methodology, do the implementation, and then basically communicate, present the use of like why you would apply this methodology and how you would use it to our digital teams, so that then they can go and use that calculator in practice. And it's it's still being in use today. So this project had a fair bit of I guess talking to, well, at least a particular group of, I guess, stakeholders, being the essentially developers and product managers in our digital team, and kind of helping them to deploy more, I guess, correct statistical methodology. And there was all sorts of considerations, of course, integrating actual data from the warehouse, as well as having this calculator deployable and accessible, having authentication. So a lot of practical considerations went into its design. So that was one example. I mean, another example that was, I think, quite interesting as well. We had a graduate also develop essentially a system for calculating, well, let's call them optimal, I guess, optimal premium adjustments. Let's call them that way. So where we had essentially a large linear programming problem. Hopefully you'll learn about linear programming in the course. If you do the Masters of Business Analytics. It's a classical, I guess, optimization technique where you are, well, basically able to specify the objectives you're trying to optimize, your decision variables and the constraints. So in that particular situation, we had one solution already implemented with a custom solver. Then the project that we had a graduate work on involved reformulating the problem as a linear programming problem from the original custom formulation. Implementing it, the model using a particular solver software, and then building a user interface for configuring constraints. That tool is now being used again by another team in carrying out, I guess, the sort of the regular operations. It is being run effectively on a weekly cycle. So in the development of this tool, I mean, they had to talk to, again, both the people who would use it operationally, as well as people involved more on the, I guess, portfolio product management side, to understand their requirements and needs and make sure that those sort of adequately reflected in the problem formulation. So that was, I think, another good recent use case.
Oh, thank you. Yeah, so it sounds like students will have the opportunity to apply the skills that they've learned in the degree program to solve business problems that are of value to the organisation, and maybe see some of the older methods that have been used in the past and relied on in the past being updated, taking advantage of modern technology and modern approaches that we'll teach you about in the program. So it's a very much an applied kind of program, and the graduate roles are linked to that as well. Yeah, and over to George again.
Yeah, that's very interesting. So there are quite, it seems like there is a wide range of problems that you employ analytics in at IAG. Can you tell us maybe just a little bit about the technology that you would expect your graduates to have knowledge of, in terms of maybe computer programming or computer languages? Is there a preference to what you employ or implement in analytics? Or are they able to do basically whatever language they are comfortable with? Or do you have any preference in terms of technology that you use?
Yes, so generally speaking, I mean, for going back for a long time, I guess we have been using some of the standard statistical software, such as, let's say, SAS, or even in some BIS organization, SPSS. But that is kind of going back some years. Since then, however, there was like a strong push across sort of our technology space towards open source solutions, kind of right across the organization, and analytics is not an exception. So now I think majority of the work that we do is done either using R or Python in terms of the basic sort of programming environments. Of course, with R in particular, there is very large ecosystem. So we do sometimes preference certain like R packages being used instead of the others. Just to ensure general consistency and sort of ease of understanding, particularly when it comes to data manipulation or certain modeling tasks. So we do have some preference. Of course, people are free to use whatever they want for, I guess, for exploratory data analysis. But yeah, when it comes for production system, there's some restrictions, but it's still very much within the sort of largely within open source universe and open source tooling. From data access point of view, I mean, there has of course been a bit of an explosion of data access technologies in the last 10 years, but we very much we're still mostly working with SQL dialects of various kinds. So in particular, if you're familiar, let's say, with Postgres SQL, which is probably the best known and most widely used sort of open source SQL engine, I think you'll be in quite a good place. There are, of course, some other systems with some slight variations, but I think they're quite straightforward to pick up as you kind of working with them. We've also been using trying to shift some of our work to the deep learning sort of frameworks with automatic differentiation and so on. So some of the tools like PyTorch is sort of another type of tools that we have been using that are somewhat new, I guess. But yeah, basically, I'd say R, Python, and SQL would be the sort of technologies that most desirable.
Open source technologies.
That's right.
Yeah.
Right.
Yeah,
thanks.
it's certainly consistent with the approach of research within universities, and also the way we teach on our programs these days. I think George, you use Python in your unit in the program. Yeah.
Yes, absolutely. So we really have a push. We have an applied predictive analytics unit where we do a range of predictive problems. We also enroll in, I don't know if you're familiar with Kaggle competitions.
Yes.
So we test our skills on real world problems, and we implement all of that in Python, basically. Yes. We also have a range of other units which cover R.
Yeah, no, it's excellent. I mean, IAG also has run several internal, like Kaggle style competitions as well for different problems. So yes, so I think that's quite a promising approach once you've got the problem well defined.
Yeah, indeed. And look, as our final question for you today, Dimitri, perhaps you could tell us, what advice would you give to a student, perhaps someone who's finishing their undergraduate program and is interested in business analytics? What advice would you give to them as they're looking to carve out a career in this space?
Yeah. Well, I think so far, especially if you are, it kind of depends. You probably need to have a think about which area you want to go and work in. So particularly in digital companies, so like Google or Amazon, so some of the analytics sort of discipline and processes are a little bit better understood and better embedded and perhaps more standardized. So I think generally speaking, you can expect problems to be somewhat better defined just because the analytical maturity of organizations is somewhat greater. So if you're interested in, let's say, hardcore AI research, like if you want to improve performance of, I don't know, voice recognition systems, you probably need to find companies that specialize in that area or have business in that area. Whereas if you look into the broader business world outside of technology space, I mean, it very much pays to be, I guess, a generalist, just because analytics is a very, very broad field. It's really can be applied to just about any sort of management question that emerges within the business. So it's really good if you have the right sort of tools to be able to bring to bear to the problem being asked. And you are dealing with all sorts of things. So sometimes you may be working with, let's say, a really straightforward or optimization problem. Maybe it has something to do with routing or allocation of some actual physical resources to some physical locations, things of that nature, where, let's say, tools from operations research can be quite helpful. Conversely, you can be in a situation where you can run controlled experiments. That's where you probably want tools from sort of classical statistics. You may want to do some sort of personalizations or targeting. So then maybe the techniques like uplift modeling kind of from marketing or contextual bandits from machine learning literature, those become more relevant in that setting. And sometimes you have to do with really vague and broad questions, let's say around understanding, customer thoughts about your company. So you're really entering almost the area of some kind of really questionnaire design or like psychometrics or the side of things people do in marketing science. So generally having a broad coverage is very valuable. And finally, I think another area that I think is generally not well covered in many different disciplines is that of, I guess, causal inference, or really causal inference from observational data. So sort of economists perhaps have in applications have spent the most time developing the methodologies. So getting a good handle of what do you do in situations where you can't run experiments, but you still want a causal answer, sort of what has caused this, and you want to avoid various sort of confounders. That's probably another very important general set of tools to get across. So yeah, and unfortunately still to this very day, as you can see, it draws from quite a number of university departments. And the program, like the business analytics program, is really a good collection of these diverse topics.
So what you've heard there is a number of different areas of application, and it won't be possible for you guys going through your program to learn every single one of those. But what you will learn are the skills and a good understanding of sufficiently many algorithms that you're able to turn your skill set to a new problem when it arises. And that, I think, is one of the most important things for a professional in business analytics. Is you're a generalist and you're able to adapt your skills to a range of different problems, and you'll have some specialist knowledge, but you'll also be able to turn your skills to new problems. And I think that's going to be important as we move forward in this space. So, well, thanks very much, Dimitri, for your time today and for answering our questions. I think I'll pass back to Ben now.
Fantastic. Thank you very much, everyone. That does bring us to the end of our webinar. So just from me, I want to thank you all again. So thank you, David, George, and Dimitri, for joining me today and talking us through the courses here, as well as some of your own experiences. So a quick reminder for everyone that this session has been recorded, and we will be sharing it with you along with other on-demand services next week. So I'm just going to share my screen. So with everyone mostly being at home and remote, a reminder that we have one-on-one consultations able to be booked. So if you have further or any questions that weren't answered by this presentation, feel free to jump online to the website on the screen and book a one-on-one consultation to get all your questions answered. That's all from me. So thanks all again, and we'll see you next time.
Thanks, Ben.